I've already given you precursors. Have I got some kind of superbug? Don't touch me. Don't come too close to me. Things like that. All right, so good afternoon, ladies and gentlemen. My name is Boyajian, Senior Solutions Architect with Liquidware, and we're here to talk about the top 5 successes and failures of an AWS or Amazon Workspaces migration. So this is what we're going to be talking about today. We're going to talk about the migration lifecycle, and we're going to talk about our successes, and we're going to talk about our failures, and we're going to talk about all kinds of really cool stuff. But before we get to that, the first thing I want to talk about is, why is it that this guy who's at the front of the room in a suit looking like a chubby version of Seth MacFarlane is actually qualified to tell you about what actually does work and doesn't work inside of AWS? Well, the funny thing is, my position in my company puts me in a very interesting area, which is we do a lot of different things for a lot of different people. And we believe in something called the 4 phases of desktop transformation. And it starts out with assessing what you currently have. What do your users consume? What do they do? What do they use in terms of CPU and memory and IOPS and networking? And we use all that information to create a design. So what you need to build inside of AWS to actually make these people work and make people happy. And then we also make these tools that do migration. So they create agnostic versions or generic versions of the Windows profile, so I can go from XP to 7 or 7 to 10 or 10 to 2016 or really whatever you want. And then we also do application layering. And then finally, we have this piece called validation through Stratosphere UX. Now the funny thing is, customers don't always come to us before they do their AWS migrations. So sometimes I talk to folks who say, I want to do this right. I want to be involved with all 4 phases. Let's do this on the ground floor, greenfields approach. And you guys are going to give us guidance every step of the way, along with your partners like Green Pages, et cetera, et cetera. But we don't always get that, do we? We have some folks who come to us and say, you know, we've just migrated 40,000 people into AWS, and it's just not working. Or I have people who are complaining, and I don't know if they're really complaining or if they just want their laptops back. And sometimes I have people who are just doing some weird stuff, and I don't really know where to start. So the reason it puts us in such a unique position is because I get involved with these companies at all different phases of this transformation. Sometimes I'm dealing with folks who are doing this from the ground floor. Sometimes I'm doing it as a kind of a post-mortem of why did it fail when you didn't talk to anybody else. And sometimes I'm doing it as an AWS 2.0 of, well, we did this pilot, it worked okay. We want to do this from the ground up to do a really good job this time. How do we go and do it? So the cool thing is I get to see all the goods and all the bads of what these organizations do. Now, for the safety of my clients, the names and faces will be changed to protect the innocent. I'm not going to actually mention any client names, but the largest clients that I work with inside of the AWS community include environments of 40, 50, 60,000 concurrent users, so I've seen a lot of weird stuff. We're going to talk about all that weird stuff today. So that's what we do in terms of an Amazon Workspaces migration lifecycle. Ideally, if I can get in at the ground floor, I want to start you here with an assessment. I want to design the environment with and for you so you can basically figure out what different frames and machines you need. I want to help you migrate to that environment so your clients don't have any kind of speed bumps or headaches. Everything on your current device should get migrated into AWS. In other words, we shouldn't have to leave things behind. You shouldn't have to re-customize things. You should keep your desktop background, your cookies, your favorites, your history, your application settings, and most importantly, your applications. All these things should be automatic, and that's what I mean by migration. And that's when once we've gotten past that point, how do you keep the wheels on the bus? How do you make sure that if you introduce new software, the environment can handle it? If your users are complaining, they're complaining for the right or the wrong reasons. And when they do have a problem, how do we go and troubleshoot that and say, the problem is X, let's go fix X? Well, the problem is, without a plan like this, you can't do any of those things. And that's an issue, because if we just say, all right, we're going to deploy some AWS, you're going to get a brand new machine, it's going to be a completely blank template, you can drag and drop your stuff there, how much time are your users going to waste moving their documents over, or setting up their desktop personalization, or getting the look and feel of Explorer the way they want it, or setting up the desktop background with the kids around the Christmas tree? You waste days on that kind of stuff. Not to mention the whole implication of deploying your software to it. So the idea here is, if you follow this process, everything should be seamless and everything should be transparent. So let's talk about how we can make this seamless and transparent on the road to success. Isn't this nice? Google finds the coolest stuff when you just type in words and click images. And I thought this seemed nice and peaceful and serene, so we're just going to go with this. So let's talk about the first 5 things you can do to help guarantee success during an AWS migration. Number one, using an assessment to design a proper AWS infrastructure. Now, basically what we're doing here is I want to take, at a 1-to-1 ratio, all the clients that you have. I want to put a tiny little agent on their machines. Preferably, it should be something what we call hyper lightweight. So uses very, very little resources, less than 0.1% of a single core of a CPU, less than 25 megabytes of RAM, less than 1 IOP per hour of disk transactions, and less than 100K of network. And using those confined resources, I need to scope out everything that you do on that machine. So I need to know what applications you're running. I need to know what's going on with all your perfmon and kernel metrics. I need to see inside of WMI so I can figure out how many monitors you have, how many IP addresses you have. Do you use a VPN client? How many printers do you have connected? Do you have any weird USB hardware that I need to know about, like a disk burner or a scanner or things like that? And I need to do this over a long-term period of time. And typically we recommend around 30 days because generally if I see a client's behavior long enough, I will get a general understanding of what you consume as a user. So your CPU consumption, your memory, your IOPS, and your network. And now that I know that over a long-term period of time, I can tell you, you need X. You need an EC2 M.2 frame with quad cores, 8 gigs, et cetera, et cetera. But the problem is, if I don't go through this process, what do I wind up with? Well, what I wind up with is what we call the one-size-fits-all approach. And this is the way that most companies do things nowadays. They say, well, we're going to move 30,000 people into AWS, and we're going to let the accountants figure out what we're going to buy. And the accountants say everybody needs 2 cores and 4 gigs of RAM, which sounds like a great idea from a financial standpoint, but the problem is that people don't work the same. So, and I thought this image was amazingly apt. So let's talk about the Johns and the Janes of the world. So let's say that you have one department in your organization, and let's call it human resources. You got 2 people in human resources that do exactly the same job, John and Jane. Now, John is a bad user. John's a lot like me. So what John will do is he's got 20 or 30 different tabs open in Chrome. He's got IE open at the same time for no discernible reason. He's got Firefox open. Sometimes he uses Opera. He's got 10 other applications open. He never saves his work because God knows why would you do that. He never logs off. He never reboots his machine. And as a result, John's consumption is high. Now, Jane is the unicorn of users. She's only got a couple tabs open. She's got Outlook and Word open. She saves her work. She logs off. She reboots. She does all kinds of good things. Now, even though they do the same job, think about that in terms of consumption. John's consumption is exponentially higher than Jane's. Now, there's a couple different ways you can use this information. You can go and beat John over the head with a stick and say, close your apps, close your tabs, and close your work. Or you can say, I'm going to embrace what you do as a user and give you the resources you need to function exactly the same way in AWS as you do on your current physical or VDI or whatever box you happen to have. Now, when you do things like that, what you find is 2 things. Number one, users will complain less because you're giving them the resources they need to function, and users will not try to hide things from you. Because immediately, the second you tell a user, you can't do that, what is a user going to do? Everything in their power to defy you, because that's what users want to do. So this isn't just about understanding the ones and zeros about making an environment work. It's about assessing human behavior and using that to say, I don't have one size fits all. I have 8 sizes that might fit all, or maybe 10. I don't know what's going to work for you. I have to see how your users have different groups of standard deviation and take those different groups and apply them to what Amazon offers and says, of the 50 machines that you can select, these 10 are what your users need, and these are the groupings, and these are the names that are assigned to each one. And that's the first step to success inside of AWS. The second one, anybody here a Futurama fan? Anybody? Okay, there's like 2 people. Now I feel weird. So some of the big things that I notice when people go into an Amazon environment is they think, number one, well, I should build my own images because I've been doing it for the last 25 years. I'm pretty good at it. I'm going to continue doing it. The problem is that when my users do this, they often take the easy way out. And they say, I'm going to deploy a Windows ISO, and that's it. I'm just going to, Oh, we're cool. I'm going to stuff all my agents in there. I'm going to do whatever we normally do on the desktop and expect that that's going to work. It's not going to work. Why? Because we don't have the same resources in AWS that we have in physical PCs. Our job is to make things more efficient and streamlined to match user behavior, not to jam a system full of stuff and just see how it runs. So the biggest bang for your buck that you get inside of AWS is image optimization. So you'll find that Windows 10, which ideally most people that are doing the transition from 7 to 10 are also doing it as part of their AWS deploy. So I often get customers say to me, well, what's the difference between 7 and 10? The resource consumption difference is normally around 15 to 25%. So just off the top, you're going to use 15 to 25% more resources in 10 than you used in 7, with the exception of 2 months ago. So about 2 months ago, we started seeing all those Spectre and Meltdown patches finally hit the enterprise. And what happened? Well, if you deployed them on Windows 10, the hit was around 2 or 3%. But if you deployed them on Windows 7, the hit was 20%. It was a huge kick to the ribs for everybody here. So for the most part, 10 is going to consume more unless we're talking about Spectre and Meltdown. But what we want to do is remember a couple key things here. Number one, image optimization tools are a good place to start. They're not the end-all, be-all of things. You've got to do your own optimizations. Figure out what works well for you as a company, and then script it and own it. Make it yours. So as new versions of Windows come out, which we're going to get at least one a year for the next God knows how many years, you can just take your scripts, mod them, and you know they're going to work for you and your users. Next, say it with me now. Do not use P2V. I want to hear everybody say that. I'm not going to use P2V. Please. I'm not going to use P2V. Thank you. So why is P2V so bad? Because you're taking all your drivers, all your junk, all your everything that you've done in your physical machines for years and years and years and saying, good enough, let's just move that into Amazon. Don't do that. It is inefficient, it's slow, it's wasting you resources, and it's costing you money. Image optimize, use your own tools, use the Citrix and VMware tools as a starting point. Script them, and then also don't forget this. Power management's always on by default. So again, I'm going to take the name of this company out of the equation, but I had one really big company deployed a huge amount of Windows 10 in AWS, and it was dog slow. I mean, horrifically slow, way slower than it should have been. And they said, Matt, what's going on? What do we do? And I said, well, let's put Stratosphere UX in the mix, and we'll sniff the machines, and we'll see what they're doing. And they said, well, what did you find out? I said, well, you have one core. They said, no, we don't. We have two cores. I'm like, no, you have one core in these systems. I said, what the hell are you talking about? And I introduced them to something called core parking, which I did not make up. This is a real thing. So what core parking is Windows 10 will analyze your power consumption and say, if you're not using a whole lot of CPU, turn off the core. In a physical machine, this makes perfect sense. Less power consumption, better battery life, all great things. But the problem is in AWS, you're virtualizing a lot of the underpinnings of what makes the OS work. So the video card, the network card, all those things are only discrete circuits. In the background, the CPU is virtualizing them all, and Windows isn't really aware of that. So Windows says, system's not busy, turn off that CPU. And now it shoehorns all that stuff into a single core. So if you disable power management, you disable core parking, and you now double the amount of CPU processing you give to a machine. So again, this isn't just because I'm telling you it's important to do. The foundations of Windows lend themselves to optimizing in AWS. It's a very big deal. Next up, application layering. Quick show of hands, who loves SCCM? I mean, loves it. It's the greatest thing since sliced bread. No, I never get any hands on it. Ray, all right, good. So I usually don't get any hands on that. It's because most people don't like SCCM. It's big, it's heavy, it's slow. Inventory scans take a while. It uses up a lot of CPU and memory and IOPS and all those horrible things. And every time you get a new machine, what happens? The whole process starts all over again. Why? There needs to be a better way. And there is. It's called application layering. What if we could take applications, stick them inside a container, and be able to take that container and attach it to all my AWS machines at once. So if I have a group of applications that a department uses, I can take those 10 applications, put it in a VHD, and says, all right, if anybody from HR logs in, they take this VHD, they mount it, it plays their applications back, and you're done. You have now created modular applications. And the great part about FlexApp that makes it unique to the industry, it doesn't care about your version of Windows. So AWS, while it solves a lot of problems, creates a few new ones. You can't quickly destroy machines. You can't quickly say, I'm going to rip your stuff away and give you something new. However, if you create a set of modular applications, and I know I'm getting ahead of myself, but a modular profile, think about that in terms of your OS transitions or in terms of your rebuilds. User screws up a machine, rip it, replace it, the apps come down, the profile comes down instantly. You no longer have to worry about backing up and restoring these things. You no longer have to worry about SCCM making a mistake. You no longer have to worry about 16 hours of product installs before I can use a machine. It's all instant. And that's a big part of what makes application layering work inside of Amazon. Now, the next thing we want to do is we want to use software that is optimized for virtualization. Now, this one's kind of tricky, because if you go to your application vendors and you say, I need a piece of software that's optimized for VDI and AWS, they're going to look at you like you have two heads, because they don't have anything like that. So what I mean when I say this is, number one, when you're taking a look at your heavy hitter applications, the one that use a lot of CPU, a lot of memory, a lot of video, a lot of every resource you have, go back to your app vendors and make it clear what you're doing. Most of them have already heard these requests from other customers before, and they might offer you one of two things. In fact, they'll usually offer you one of two things. Number one, they might have a version of their application that has some optimizations built in. So it doesn't use a lot of GDI objects or 2D rendering that eats up a lot of CPU in AWS and VDI. They might have a version of the application that maybe has different copy protection standards, so it's easier for you to deal with. They might have a couple of services that removed. And if they don't have that, what they will have is a set of optimizations that you can run. So if you run this registry script, we're going to turn these things off inside the app and make it run a little bit more efficiently. Why does that matter? Well, it matters for a lot of reasons. I previously mentioned something called GDI objects. GDI objects are all the little rasters and fonts and frames and things that Windows needs to keep track of in order to render it on your screen, to paint you a picture. The more of those things that you process, the harder your video card has to work. Do you have a video card inside of something like AWS? No, you don't. So to my point before, the CPU has to render that for you. And if CPUs were good at rendering video, we'd be buying our, if GPUs were good at rendering video, we'd be buying our GPUs from Intel instead of NVIDIA and AMD. They're not good at that kind of very specific behavior. So what happens is, as you start to push more and more and more GDI objects, the CPU starts to eat that up, and that's very inefficient. It's even worse when we start bringing 3D into the mix, because 3D is even exponentially higher of a consumer than 2D. So if I start doing 3D acceleration and high GDI object rendering, I'm going to saturate my CPUs in AWS, and I'm going to bring the whole system to its knees. Well, how do we fix this? Optimization. So a couple good examples. Windows 10 has automatic 3D acceleration built in to take the load off the CPU. Turn it off. See the whole thing we talked about in terms of image optimization. Microsoft Office, which pretty much everybody uses, does the same thing. And most people don't know that. So starting with Office 2010, they have incrementally added more 3D acceleration features as Office has evolved. So 2010 was the first incarnation, some 3D offloading for Outlook and PowerPoint. 2013 came along a little bit more. 2016 came along, and they're throwing everything in the kitchen sink and try to get this rendering to be done by the 3D GPU. And the more that you do inside of AWS, the worse it gets. Well, the good news is you can turn it off. And this is what I mean by optimization. If you turn off the 3D acceleration functions in Windows itself through Arrow or whatever the hell they're calling the interface now, and turn it off through Office, that's going to help decrease that CPU load and the 3D load and the 2D load. The other thing that people forget about is your browsers. Every modern browser uses some form of 3D acceleration. Google Chrome uses a huge amount of it. Firefox does the same thing. IE, Edge, they all do it. So if you're not aware of these things and you just have the regular old 3D video card stuffed into AWS, all those apps are going to use it, and they're going to chew up huge amounts of CPU doing it. So when I say optimization, it's not about just getting the stuff from the vendor. It's recognizing a lot of these options are already available to you. You just have to turn them on. So security software. this is a personal sticking point for me because me and security guys don't get along. And I'll come in and I'll say, here, you got all this crap in here. Let's turn all this off. You don't need that. And I actually had one security guy get really upset with me and pound his fist on the table and say, I will not sanctify security for the sake of speed. Actually said that, not even kidding. And I said, all right, what are you defending against? And he goes, everything. We have attackers from here and there and everywhere. I'm like, all right, cool. If you've got an employee with a laptop and they drag it into Starbucks and they connect to a public Wi-Fi, I will grant you that is a fairly insecure environment. But if I have a box inside an AWS bunker somewhere, can we at least agree that they're not in the same ballpark, that inherently the design of AWS is a little bit more secure than a laptop in a coffee shop? And he said, well, yeah, I'll give you that. Well, I said, okay, if you can agree to that, then you can agree to the fact that maybe you don't need 6 different security agents installed inside of your operating systems. And I would agree the same thing here is the case. In AWS, I want you to scrutinize your agents to say, just because this was necessary in a physical world does not mean it's necessary inside of a virtual world. In other words, do not use the everything and the kitchen sink approach because ultimately it's going to cripple you, and that's what I'm here to stop. All right, what's next? Increasing productivity through profile migration. Now, I kind of spoke about this a little bit earlier, but we said that we can start treating operating systems as modular entities. And ultimately, there's 3 parts to this whole modular entity theory. There's the OS itself, there's the application stack, and then there's the profile itself. The profile itself needs to be agnostic of its version of Windows. And the problem with that is Microsoft has made that immensely difficult over the last 5 years to even achieve. So because what they used to do was, with Windows XP and Windows 2000, we had one profile format called V1. So everyone remembers C documents and settings and the good old days where everything was really, really easy. And then a whole bunch of viruses and malware and spyware came out, and Microsoft said, let's use the security through obscurity approach, and we're going to change some reg keys around, and we're going to move from documents and settings to C users. Okay, whatever, fine. That's what we call V2. Then Windows 8.1 came out, and Microsoft said, we're clearly not sending you enough advertisements. I mean, really, that's something that you should be seeing in your operating system is ads for Tide. It makes sense, right? So what they said was, we need to be able to stick advertisements inside of your profile, and that's where the first underpinnings of Windows 10 came from. That's where the V3, V4 profile came out with. And then Microsoft came out with Windows 10, and it was a bit of a mixed reaction because on one hand, it was fast, and it was fairly stable, and it gave us the Windows Store. But the big thing that Microsoft loved about it was A, telemetry reporting. Yay, we get to spy on all our users. And B, advertisements directly through the start menu and tiles. Great, right? Well, no, because Microsoft kind of didn't get it right the first time because they created a whole database around it, and the database would crash, and it was locked, and there was no API, and it made a mess of things. So they said, all right, with original Windows 10, we're going to give you a database, and we're going to change the database in 1511. And then they said, well, we're going to kind of use the database and the file system in the registry, and that gave us 1607. And then 1703, they just said, screw it, we're not using the database anymore. But the database is still there. Why? Who knows? It's Microsoft. You just do any random thing, and you can explain Microsoft's behavior. But the problem is now, how many different profile formats has that given us? 8. We now have 8 different profile formats to worry about. So we need to figure out a way to make the profile generic and specific at the same time. How do you do that? Well, a lot of companies have a different approach. This is ours. We looked at the registry, and we said the registry is kind of a unique place because there's some parts in it that haven't changed since the Windows NT 3.5.1 days. And think about that. NT 3.5.1 came out in what, 93, 94? There's some instances of the registry that haven't changed in that time. So if you look at HKey current user software, that's one of those generic areas. If you look at cookies or favorites or history, those are those generic areas. So we said, why can't you segregate those sections of the profile as different, hardened, fault-tolerant modules? So I have all these 30 different sections of your third-party apps and all those different things, and most of them, read 90%, are generic. I can take them out of the registry and of the profile, app data, and I can plug it into another version of Windows, and it will work. But there are some parts of the profile that are specific down to your service pack or subvariant of Windows. Places like Active Setup, which starts up when you first load your profile. Windows themes, which Microsoft endlessly changes. So by segregating those two areas between generic and specific, I can now have a profile that can live on any version of Windows that I want. And then what we also want to do is we want to make the profile hardened, because who here has ever experienced some form of registry corruption in their lives, in their professional careers? Anybody? Wow, that's a lot of hands. Our job is to make that stop happening. And the way that we do that is, first, we keep the registry native. Taking end-to-user.data and putting it on the network is just going to make things worse. See what happened with Microsoft with roaming user profiles. So instead, what we want to do, keep the registry local. That's number one. Nice, simple, it works, it's safe. Number two, I want a secondary copy of everything that you're doing. Number three, I want to be able to CRC it, cyclic redundancy check it. I want to be able to compress it, make it as small as possible. The registry.reg files are based on 7-bit ANSI. You can get a 50-to-1 compression ratio right out of it. You should use that when you can. Number three, I want to hash it. And number four, I want to check that 7-bit ANSI for corruption. And the easiest way to do that is make sure it's 7-bit ANSI. When you get registry corruption, it shows up as 8-bit. And not to drag you back to the dark ages, but that's the difference between Usenet versus modern web, 7-bit versus 8-bit data. If you see 8-bit data in the registry, you've got a big problem. Now I can throw that line away, and I can restore it from a backup. So that's the fifth thing we're doing. Because we're compressing these things, and because they're so small, make a backup of them. So that's the nuts and bolts of what makes all this work. If your eyes are glazing over and you don't care about any of this, let's talk about what the end result is. The end result is you have a registry and a profile that doesn't care about your version of Windows. Anything that Microsoft has built in the last 17 years, this will apply to. So if your AWS user needs a machine rebuilt, they don't lose anything. If you want to migrate from Windows 10 1703 to whatever, I don't know, 1709, 1803, 1809 when it comes out, you can do that without penalty because it's designed to be modular. Now, in addition to that, I also want to leverage other things that Amazon has been really kind enough to give us that work really well. Who here loves designing storage platforms? No hands. I never get any hands on that. So the good news is Amazon's done all that for us. They created S3. And S3 is easy, and it's fast, and most of my clients are using it as either a DR or a primary module to store things in. Why can't I store my profiles in there and make it agnostic not only in terms of AWS, but also in terms of desktops, laptops, and VDI? Well, the answer is you can, and you should leverage tools to do that. And now's about the time where I usually stand on my soapbox, because if I were sitting in your shoes, listening to some guy pontificate endlessly for 25 minutes, I would say, what's his end game? Is he a sales guy? Is he making money off this kind of thing? So I am an architect, which means I don't care what tools you choose. Jenna's my account manager. She's grinning right now because she cares what tools you choose. But I don't care what tools you choose. I just care that you're following best practices. So what I think you should do is go and research the companies that tools work best in this kind of environment and know to use them. I don't care which vendor you choose. I just care that you're doing it the right way. So again, going back to the whole 4 phases of transformation, with the assessment, with the migration, with the validation, with the whole piece there, as long as you're doing it, I'm happy. But if you buy from my company, that'll make Jenna happy, and we like making Jenna happy. So anyway, back to this. This isn't just about S3 either. And I know we're at AWS Day, and I'm supposed to be talking about Amazon, but we should be agnostic to this as well. We should work inside of Google Buckets. We should work inside of blob storage, and we do all those things. One of the presentations that I went in today, we were talking about how easy is it to move from one cloud vendor to the other. Well, if you lock your profiles in one, you can't do that, can you? We give you the out, we give you the options. We clearly think Amazon's the best one, but just in case things change 5 or 10 years from now, you're not locked into any one thing. What else can we do? Oh, hang on, one last thing. Remember when I was talking about you can do application layering through what I called flex apps, those modular application packets? We're going to be able to do that directly into S3 soon. So you're not going to have to provision your own servers, your own EC2 storage, anything like that. You can provision applications directly from S3. Now, when I say stuff like that, the wheels start turning in people's minds, and they usually say, well, what if something goes offline? What if I lose something, like the network or the S3 drive or things like that? We're introducing caching at the same time. So if you lose the network, if you do this on a laptop, if you do anything in a desktop or AWS, and something really goes bump in the night, you're fine. It's going to be cached locally. Last, if you don't want to use S3, there's this nice, relatively simple mechanism to deploying it. You can put your profiles and your applications out there by deploying one system, one profile Unity box. That's going to push out its agent to your netlogon shares where it gets replicated. If that goes down, everything stays safe. We can use folder redirection to make sure that your document stays safe in whatever agnostic fashion you want. We can use S3. We can use our own UNC pads. We can use whatever I want. And the point of this is you should have multiple choices when it not only comes to your profile formats, but also where you're storing them and how you're storing them. All right, now comes the fun part. Where did I see people really screw up? So if you're looking for the train wreck part of this presentation, this is it. So let's start with train wreck number 1. Using slow and cheap storage. Who's got AWS machines available right now that they're using? I see more than a few people. About, what was it, a year, 18 months ago, Amazon came out with the whole SSD thing and said, hey, if you want to use SSD instead of spinning disk, here you go. It was a really, really, really cheap option. Did you guys capitalize on that as soon as it came out? Okay, you guys did. Most of my big companies did not. Why? Why didn't they just say, destroy the spinning disk machines and move to SSD? It didn't really cost anything. The storage performance was exponentially faster. And by the way, storage is the slowest subsystem of any computing system you work with. So when you think about the CPU and its billions of instructions per second, or memory with its billions of instructions per second, and then you talk about the hard drive with its hundreds of operations per second, there's a big, big delta between those things. Any improvements you make in speed of storage translates into better user experience. Just like how when we got SSDs in our laptops, things got better, Windows ran better, apps ran better, AWS is no exception. So I went to my big clients and I said, hey, your storage sucks. I can see it from here. I'm using Stratosphere to monitor it. You got disk queues that are just absolutely insane. Destroy the machines and rebuild them. And they said, oh, we can't do that. Why? Well, because we built everything into AWS and we're using classic deployment methodologies. And if I want to destroy an operating system, I have to destroy the user profile and the apps and everything that the user is doing along with the ride. So if you don't subscribe to this modular philosophy, doing something as simple as switching out your storage is almost impossible. So think about this in terms of the advancements that Amazon's been making just in AWS over the last 5 years. They recently updated, for example, the NIC speed went from 10 gigs to 25 gigs. They gave us SSD instead of spinning disk. They gave us newer hardware from a CPU perspective, which was really nice. The new formats are really cool. All the V4 Xeons that they're employing now are really, really fast. The V5s are also really good. Now, what if you could never do that? What if you could never go to the newest, latest, and greatest hardware? Well, that's what most of my big companies are facing, is they have to deploy new machines or keep the old ones. They can't just rip it down, throw it someplace else, and expect everything to just work. But if you subscribe to a modular application and profile approach, this is child's play. Destroy a machine, spin a new one up, the user logs in, the translation's instantaneous. They never even knew the machine was destroyed to begin with. They just noticed, oh, suddenly everything's a whole lot faster. Don't use spinning disk. Spinning disk is the devil. All right, next up, not measuring user experience. So who has users that call into the help desk incessantly every week and complain about things? These things can be anything. It could be my laptop's slow, or VDI's slow, or my monitor's not big enough, and my neighbor got 16 gigs of RAM. Anybody heard of this before? Anybody? A couple people. Now, the problem is it's really, really hard to separate the signal from the noise. And sometimes what you have is you have users that sometimes users that shouldn't be complaining are complaining, and sometimes people who should be complaining aren't saying anything to you. So the questions that I want you to ask yourselves are this. How do you know what users are running on their machines? I've gone into environments with Stratosphere a lot, and the amount of time that I come away with World of Warcraft, or, no, I'm not joking, I saw those eyes go, that was great, or Unreal Tournament or Doom, the amount of times that I've come back with things running where they shouldn't be is staggering. And we all have a lot of really good inventory tools, but I want to make sure that everything running real time is being captured. So that's the first thing. How do you know what users are running their machines? If they call the help desk, do they really have a problem? What about users that don't call? Are you monitoring your connection broker protocols? And I'm going to come back to this in a minute. Do you have machine-level predictive analytics? Can you provide a single interface that is tailored for different teams? So in other words, when you have tools that do stuff like this, you have 6 different teams that traditionally don't like to work together. You have desktop, you have server, you have network, you have storage, and you have management. These people don't like each other. They don't want to work together. And if you give one team a tool to use all this stuff, what's the other team going to do? They're going to buy a different tool just to say, hey, we need this visibility too. Don't do that. Give them tools that have different interfaces so everyone has access to the same data, but in the way they want to see it. And the way that users and team members want to see this data is going to be different based on who they are. So for example, my engineering staff is going to want to see the bits and bytes, the ones and zeros of everything that's running on that box. So they can tell the user when they call in, yeah, you're complaining about slow storage. You say you need more RAM. You've got 60 copies of Chrome open. They've been running for 14 days. Maybe if you close some of these, some of your memory problems will go away. And oh, by the way, you're only using 8 gigs. You don't need any more. So whereas the help desk wants to type in a user's name and be able to get tons of information on that user in a very, very simple way that anybody can read. Whereas management wants lots of pretty colors and reports and charts because that's what managers want to see. And then you have your operations team. They want to see something like this. They want to see a view of the world that tells them right now what's right, what's wrong, what needs a pickup of the phone, and what doesn't. And then you might have another team, like, for example, the server team that wants to see high-level metrics, but still gives them a good amount of data. So what you want is something that has multiple interfaces to meet the needs of different team members, so you're not fighting all over the same tools. Doing things the way you always have. So when you translate from physical or virtual into VDI, if you don't change anything in terms of how you're doing it, in terms of your deployments or your processes or your agents or your inventory or anything, you've automatically failed. So if you come to me and say, hey, we were able to take all the same teams and people and we minimized the amount of work that we had to do and we only had to change one job function, we did great, right? No. What you should be doing is reinvestigating every single minutia of what it takes to develop a system and put it in someone's hands and say, is this the right way for doing it if I'm bringing it to the cloud and I'm paying by the hour? Because ultimately, the less resources that these users consume means the less money that you spend on it. It is a direct relationship here. So if you keep doing things the way that you always have, it's going to break every single aspect of making this project succeed. So if you're not leveraging most of all the successes that you've seen here, you're automatically going to fail. Siloed departments, what I was talking about in terms of the departments that don't like to get along with each other, that's a big part of this. People in different teams, especially if they've worked with each other for a long time, they might hold grudges. And when you have departments that are very specific and monolithic, like everybody hates the networking team, or the storage team doesn't want to deploy anything because it's the storage team, I see somebody laughing in the back row. You have to get past these issues. How do you do that? Well, I'm actually going to show you in the next couple minutes. Next up, artificially restricting user resources. Who remembers this guy? 640K ought to be enough for everybody. Yeah, sure. 640K, doesn't that sound great? Well, the problem is we don't learn from history very often. And I can't tell you how many times I've gone into an organization and they say, well, we want to do AWS, but the accounting department has a real hard time with giving anybody more than 8 gigs of RAM. They just don't think it's necessary. Or you know what, giving somebody more than 2 cores, why would you need more than 2 cores? I mean, everybody should be fine with 2 cores, right? Well, think about the amount of hardware that you get when you buy a cheapy i3 laptop from Best Buy. New i3s have quad cores, and by default, you get 8, 16, you can get 32 gigs of RAM in a laptop, and yet we're saying for a professional grade development solution, 2 cores, 8 gigs should be fine. Don't do that. What you should be doing is going through the assessment process and figure out what people need. not what the accounting department tells you what you should have. And again, 3D and 2D processing, you don't have a GPU in any of these systems. That means it's all going to fall on the CPU. And if you do things like turn on core parking, everything's just going to come falling down like a house of cards. Yes, sir?
Could you spend a minute describing what AWS bundles are? Because I think that would really help everybody.
Yeah, sure. So the idea is that when I was talking about the different permutations of AWS boxes that you can buy, right now with Amazon, you can pretty much customize whatever you want, or you can just choose from the existing bundle lines that they have. So in other words, you can choose between spinning disk versus SSD. You can choose between 1 core, 2 cores, 4 cores, 8 cores, 16 cores. You can go all the way up to 32 right now if you want to get really nuts with it. You can bundle that with higher bundles of RAM. The idea is remember when I was talking at the beginning of this presentation about the assessments? Well, the assessment should tell you which bundle works best for each group of users you have. So if I have 5 different bundles that our tool has said will work for you, and each one of these bundles get assigned to a user, you now know exactly what user needs what bundle to A, meet their consumption needs, and B, do it as cheaply as possible. Does that make sense, Ray?
Yeah, in a pre-sales capacity too, which is pretty cool. So we can really help guide you towards an AWS project or a workspace as well in that way. So a lot of people get frustrated that they don't know which bundles to take. So it goes hand in hand. So.
Yeah, that's a big deal. Thanks for that, Ray. All right, next up, what else? Blaming everything but the connection. This one happens a lot. So anybody here have DSL? Anybody? Now, I know you don't want to raise your hand. Let's be honest. Who's got DSL? I know Ray's got DSL. Anybody else? No? Well, you're lucky. More often than not, when I run into my connection sucks, or my VDI sucks, or my AWS sucks, I go into a lot of different things and learn a lot about a machine and consumption and resources and what the user's doing it. And 9 times out of 10, the last thing that is ever even talked about is the connection. If you use DSL, your connection's going to suck. Most of your users are going to have it at home. You can make it work, provided that you don't combine it with wireless, because wireless plus DSL is just awful. But people do it all the time. And we have to make sure that we're accounting for all these things in terms of things like session latency, image quality, packet loss. If you're not examining the broker protocol, you're doing yourself a disservice, and you're just going to be spinning in circles until you really can't figure out exactly what the problem is. So our software looks at all these things, including things like the connection broker protocol. Now here comes the bonus piece. So before I said what happens when departments are siloed and you have infighting between people that don't want to work with each other, and you have all these issues where departments carry grudges for years and years and years. What I've seen successful large-scale companies do is define a champion. So in other words, somebody that can rise above all the departmental issues and say, listen, you're going to do this just because I say so. And you can use whatever approach you want. You can use a carrot or a stick approach. You can incentivize people to do things, or you can beat them about the face and head violently. You can do whatever you want. But the whole point is somebody above the departments who will say, this project is something that I am taking personally, and I have a vested interest in. Therefore, the people that work for me, you can see where I'm going with this, also have a vested interest in it. So what you need is somebody at the director or executive level to own this project and to ask the departments to work together, which is fine, but that doesn't solve the last problem of, well, how do you cut through all the red tape? How do you get people working together, or more importantly, departments to work together that don't want to work together? Well, what I've seen a lot of companies do is they create something called a virtual group. They will create a group of all the subject matter experts from all departments that need to work together, and they will basically corral them and say, okay, as part of this project, you guys are all the SMEs. It's your job to solve the problems that departments don't want to solve themselves. So when somebody says the network sucks and the network team says no, it's not, the SME from the network group will work in this virtual group with the other group to say, yeah, we can actually solve that together using a smaller set of individuals who knows the rights and wrongs of what can actually work in the environment, and they get the blessings from this champion, read executive or director, to make the project run the way that it's supposed to. In other words, bless you, this is all brand new to all of us. This is not traditional PCs the way we've been doing it for the last 25 years. This isn't even VDI. In some ways, what Amazon's done for us is taken all the headaches that we normally had to deal with, and they've gotten rid of them. The problem is that until you've gone through all these successes, you're just going to relegate yourself to failure again. So I hope you learned a little bit about what you should and shouldn't do in terms of these deployments. I'm going to be around for the rest of the afternoon. In fact, we're going to be sponsoring the happy hour here. So I never get to say this, but the drinks are on us. Thank you very much for your time. Have a great day.